Hello, this is AP Calculus BC class with Mrs. Ryu. Today we are going to cover chapter 9.4. It says comparisons of series. Okay, here is a direct comparison test. Okay, so the condition is AN, you have AN and BN, and they both are positive. Okay, and the BN is greater than AN. Okay, and it says number 1. If the series Bn converges, that means the bigger series converges, then the smaller series converges. That makes sense, right? Okay. If the smaller series diverges, then the bigger series, of course, diverges. Okay. What if I have a series Bn, the bigger series, diverges? Okay. Then what about the series AN? Okay, the answer is we don't know. Okay, because the bigger one diverges, we don't have any information about the smaller one. Okay, so this is the direct comparison test. Example number 1 says determine whether the series converges or diverges, okay? And you have a sigma 1 over 2 plus 3 to the nth power. One thing that you should know is there can be several ways to solve a problem, okay, in this chapter. So we are going to use the direct comparison test, and let's find Bn. Okay, let's say this is An, and Bn is greater than An, right? So I'm gonna have Bn 3 to the nth power, 1 over 3 to the nth power. Okay, so how about sigma Bn? So that's sigma 1 over 3 to the nth power. Does it converge or diverge? It converges because of the geometric series test, right? R is 1 over 3, so that's less than 1, greater than negative 1, so it converges, right? Okay. And then now, let's compare the AN and BN. So I have a 1 over 2 plus 3 to the nth power, 1 over 3 to the nth power. Which one is greater than the other one? Is this way, right? So yes, we have AN and BN. And the BN is greater than the AN, right? Okay. So we can say that because the bigger one converges, that means the smaller one, of course, converges. So the answer is it converges. Okay, example number 2. I have a sigma 1 over 2 plus square root of n, and let's say that is my AN. And a BN, I'm gonna say that 1 over square root of n. Okay, that's usually how you do it. You just get rid of the constant. Okay, so BN, sigma BN, so sigma 1 over square root of n to the 1 over 2 power, it diverges because of the P series, and the P series say that when P is between 0 and 1, okay, it diverges, right? So in this case, okay, 1 over 2 plus square root of n, 1 over square root of n, which one is greater than the other? It's this one right here, right? So in this case, the bigger one diverges, so we can't get any information about AN. Okay, so let's change the strategy. I'm gonna take Bn, how about 1 over n, okay? And we'll see if this works, okay? So An was again 1 over 2 plus square root of n. So which one is greater, okay? Let's take the denominators. So I have 2 plus square root of n and n. Which one is greater? Okay? I'm going to move 2 to the right hand side. And let's square both sides. Since n is the positive, so we can square both sides. Okay? So then I have n squared minus 4n plus 4. Which one is greater? I'm going to move n to the other side, so I'm going to make negative 5n. So here I have 0, n squared minus 5n plus 4. Okay? I can factor this out into n minus 1, n minus 4. So let's graph this. It's 1 and 4. It's an open upwards parabola. So it looks something like this. And when n is greater than 4, we can say that when n is greater than or equal to 4, we can say that the right hand side is greater. So it's greater, this side is greater. Okay? That means when we take the reciprocal, like an and bn, which one is greater now? It's an is greater, right? Right? Okay, so now let's see if Bn converges or diverges. Okay, if I have the series 1 over n, it diverges because of the P series. And in this case, P is 1. And we gave it a special name, remember? Was a harmonic series, right? So it diverges. Because the smaller one diverges, the bigger one, the greater one, diverges too. So my answer is An diverges. Okay, here's another comparison test. It's called a limit comparison test. Okay, so if An positive, Bn is positive, then limit as n approaches 0, An over Bn equals L, where L is finite. That means defined. It's not undefined. Okay, that means defined. N positive, then they either both converge or both diverge. That's the limit comparison test. Okay? Okay, example number 4. I have sigma square root of n over n squared plus 1. Okay, and this is my An. And let's take Bn. How about square root of n over n squared? Okay, so that we can cancel out some terms. Okay, so I have limit n goes to infinity. An, so square root of n over n squared plus 1, and divided by bn, so I'm going to multiply by the reciprocal of bn, okay, so n squared over square root of n, okay. I'm going to cancel out square root of n and square root of n, and as n goes to infinity, I have n squared over n squared plus 1, so that's 1, and we can say that this number 1 is finite. Finite means it's not undefined. Okay? That means we have a real number. Okay? And it's positive, so it satisfies the conditions. Okay? Two conditions here. So we can say that they either both diverge or both converge. So now I'm going to take Bn and see whether this converges or diverges. So Bn is what? It's n to the 3 over 2 power and 1 the top. So according to the P series, in this case P is more than 1, that is greater than 1, so it converges, right? So because Bn converges, An also converges because we got the finite and positive number. Determine the convergence or divergence of the series n2 to the nth power over 4n cubed plus 1. Okay, so we need to take Bn. Okay, and again, there can be many different ways to solve this problem, but we are going to use the limit comparison test. So how about I take Bn as 2 to the nth power on the top so that I can cancel out 2 to the nth power, and I have n and n cubed. So how about we try n squared and we see if we can get the finite and positive number. Okay, so I get limit n goes to infinity, n 2 to the nth power over 4n cubed plus 1, and I'm dividing by Bn, so I'm multiplying the reciprocal. Okay, so I have n squared and 2 to the nth power. Okay, so it might not work. Okay, then we try again, but let's see. So what I can cancel out is 2 to the nth power and 2 to the nth power. Okay, then I have n cubed for n cubed plus 1, and I have a limit, n goes to infinity, so that's 1 over 4. So this is finite because it's not undefined, and it's positive. So yes, I got what I wanted. So doesn't matter what number this is, okay? As long as I get the finite and positive number, I can say that either they both diverge or they both converge. In this case, the Bn it diverges, okay, because the limit Bn is not equal to 0, then according to the nth term test, it diverges. So because Bn diverges, An over Bn, we got finite and positive number, so my series diverges. Okay. Here's the Bible verse of the day. So I say to you, ask and it will be given to you, seek and you will find, knock and the door will be opened to you. Luke chapter 11 verse 9. Have a great day.
Now, if I were you, I would take a moment right now and say, Lord, and you're faithful. I've searched all over. I couldn't find nobody like you. You're highly exalted, and your name is above all names. That's it. Come on, help me say it. You're an awesome God. We bless your holy name. You're an awesome God. You're not ashamed.